Welcome to the extra exercises of week 5. We have a 3T and they want us to process the labels with the help of the in-order algorithm. And in the order, remember, that means we process them the second time we meet. So we start at A, so first time, B, first time, E, first time, J, first time, but then we go around. So that means second time. Then we meet E again, K, second time, K, first time around, second time, we go to B, second time, we go to A, second time. Okay, then we go to D, first time, and then we first have to visit the left tree that's empty. We go back to D, so second time. E, first time, we go around L, second time, we see E again, we go back to N, and that's it. All the elements are processed. So this is the process order with the in-order algorithm. And let's do the pre and post as well. So pre would mean A, B, C, A, B, A is it? A, B, A, J, K, D, I, L, N. And the post order, last time we visited, so A, B, E, J, this is the last time we come here, K, A, B, and then we skip A because we still have another tree to do, so D, I, L last time, N last time, I, D, A. And so in order, second time, pre-order, first time, post-order, last time. Okay, in exercise 5.7 they want us to build a prefix code, an optimal prefix code. So we'll do that with the help of the Huffman algorithm. And then the first step is we need to order the frequency with the lowest frequency first. So that would be 3, 16, 20, and then 30, 31, 35, 50, 78, 80, and 125. Okay, now we've done that, and the Huffman says you connect the two smallest together and then keep this line ordered. So let's do the first step. So 3 and 16 together will give us 19, and then the rest will just follow suit. So we keep it in order. Okay, we combine 19 and 20, that is 39, but then 30, 31 and 35 will be in front of the 39, and then 50, 78, 80, 125. Okay, we combine, and these two, I'll put them here, 61, so 35, 39, 50, 78, 80, 125. These two together will give us 74. So in front 50, 61, 78, 80, 125. 50 and 161 will be 111. So in front 74, 78, 80, 125. These two together will become the largest so far, 152. And then in front 80, 111 and 125. 80 and 111 becomes 191. Then only 2 steps left, so these two together will give us 274. We still have 191, and then these two together will give us 516, 465. Okay, and now we're going to build a tree by starting with the highest weight. So we start on top with 465, and then every time we enlarge it with the one which made the combination. So here we have 274 and 191. And then the next step was 191. This one built out of 80 and 111. Okay, it's this one. Then the next step was oh, I forgot one. This one. No problem. I can still measure it in. So 125 and 152. Okay, that one. Then we have 152 was 74 and 78. This one. Then 111 was 50 and 61. It's this one. Then we have 74, 35, 39, 61. I'll expand a little bit to the left. Was 30, 31. This one. And then we have 39 being 90 and 20, and we're almost there. 19 is 3 and 16. And if all went well, I have now built a tree where the leaves correspond with the frequencies. So now for the Huffman code, I can just follow the tree, and for instance, let me do this 80 here, that's I. So let's say we go to the left with zeros, then I is 0, 0. And this one is to the right, to the left, so this 50 is 0, 1, 0. And then the 30 is 0, 1, 1, 0. 31 is 0, 1, 1, 1. This 3, this should be the highest one, of course, so that's 1, 1, 0, 1, 1, 0, 1, 0, 0. Okay. 16, that's exactly the same one, but only the last one changes, so that's 1, 1, 0, 1, 0, 1. Then we have this 20, which is 1, 1, 0, 1, 1. And then we have 78, it's 1, 1, 1. 35, where did we find our 35? That's this one here. So that is 1, 1, 0, 0. And then 125, that's a high one here, so it should be a short path. It's 1, 0. Okay, and in this way we find an optimal prefix code for sentences with the following frequencies. So where a lot of E's happen and a lot of I's happen. Exercise 8 from the last lesson. We are given a binary tree with 9 nodes, and they're given with the help of the pre-order and with the help of the in-order. Question is, can we now draw the tree? Okay, if we start with the pre-order, then we definitely know that G is the root of the tree. Okay, this goes out. Next element in the pre-order is B, and it's still not visible in the in-order, so that means the left tree is B. Then we have Q, which also arrives at the in-order. So that means we have now Q as a left tree, but because it's also visible in the in-order, this Q itself doesn't have a left tree, because in-order processing is left tree, root, right tree. So the left tree of Q is empty. Then we see B in the in-order, so that means the right tree is also empty because the next one in the in-order traversal is B. And now we meet in the in-order C, which is not there yet, and in the pre-order Q, so that means in the pre-order A, Q we already have, so that means that the right tree of B is A. And we don't see it in the in-order yet, so then we have C, okay, left tree, C. That's the first one again we see in the in-order, so that means the left tree is empty, and because the next element is A, the right tree is also empty, and then we see A. Then the next element in the in-order is G, so that means we have to go all the way back to B, to C, and then we visit this one. Okay, so we go to the right tree, this part is left tree, we go to the right tree, and the first element we see is P. We see it in both orderings, so that means that the left tree of P is empty, because we see it here. Okay, that's good. Then on the pre-order we have a D, so we have to go to the right tree, and it's not there yet, so that means the left tree is not empty, so we have an E, and that's the one we also see, so this one is empty. And then we go back to D, so the right one is also empty, and then the last element is R. And so let's check. Pre-order G, B, Q, A, C, P, E, P, D, E, R, and so that's perfect. And then in order, let's make that one red. So in order, first time, left tree is empty, so we circle around Q, we meet B for the second time, A first time, C, left tree empty, C now, A, G second time, P, left tree empty, so P for the second time, then we meet E, empty, second time, D second time, and the last one we circle around is R. So this is a perfect representation of this binary tree. Okay, that concludes all the exercises of lessons 1 until and including 5. The only thing left is the mock exam.